Telescoping series. A telescoping series is any series where nearly every term cancels with the preceding or the following terms. In order for a series to be telescoping, we must get terms to cancel by looking at the n partial sum. For example, the first one here, the summation of 3 over k minus 3 over k plus 1, where k starting from 1 to infinity. We consider the n partial sum, which is Sn, or from A1 plus A2 plus A3, AN plus n minus 1 plus AN. For A1, or when k equals 1, we get 3 over 1 minus 3 over 2, A2, which is 3 over 2 minus 3 over 3, A3, which is 3 over 3 minus 3 over 4. For the n minus 1 term, we have 3 over n minus 1 minus 3 over n plus 3 over n minus 3 over n plus 1 term. As we see, the numbers that next to each other can be cancelled, like negative 3 over 2 plus 3 over 2, negative 3 over 3 plus 3 over 3, and same pattern as the numbers that next to each other, including the last two groups here, which is negative 3 over n and plus 3 over n. Therefore, our Sn, or the n partial sum, can be simplified to be 3 minus 3 over n plus 1. As we know that when we find the limit of the Sn, which is the same as the limit of the infinite series, so for the limit of the Sn, n approaches infinity, which is the same as the limit n approaches infinity of the sigma notation of the 3 over k minus 3 over k plus 1, k from 1 to n. Since Sn is 3 minus 3 over n, so the limit of 3 minus 3 over n plus 1 as n approaches infinity equals 3. Therefore, this series, the series converges to the value 3. In this example, which is another example of the telescoping, we have the sigma notation of 5 over k squared plus 2k. As we see this as 5 over k multiplied by k plus 2, and find the fraction decomposition of this rational form. We get this as 5 over 2 for the numerator of the first one, and also negative 5 over 2 for the second one. So we can rewrite this sigma notation as 5 over 2 as the constant multiple or the common factor of 1 over k minus 1 over k plus 2 of this series starting from k equals 1 to infinity. And then to evaluate this infinite series or find the limit of the partial sum, we're starting with forming the n partial sum, which is Sn, for k equals 1. So all of them multiplied by 5 over 2 as a common factor. For k equals 1, we have the term as 1 minus 1 over 3. K equals 2, we get 1 over 2 minus 1 over 4. K equals 3, we get 1 over 3 minus 1 over 5. Let's do one more, and 1 over 4 minus 1 over 6. And then the last term would be 1 over k 1 over n minus 1 over n plus 2 as the very last term. The one before the last would be 1 over n minus 1 minus 1 over n minus n plus 1, sorry. And the one before, the two term before the last would be 1 over n minus 2 minus 1 over n. So this way we can see the patterns of the number which they can be cancelled. Looks like the first term and the third term has the number that can be cancelled. The second and the fourth as negative 1 over 4 and 1 over 4. So it's going to be like the three terms at the first and the last, skip the middle one. That's the reason that I included the last three terms of this series. So as the last three terms, you can see n 1 over n and negative 1 over n can be cancelled. And similar way, 1 over n minus 1 would be cancelled with the one before the third term from the last as well. And keep going the same way. All right. And when you look at the simplified form of the Sn, we get Sn equals 5 over 2. Remain the first one, remain the second one, and the last two from the back of the series, which is negative 1 over n plus 1 minus 1 over n plus 2. And then we take the limit of this Sn as n approaches infinity to get 5 over 2 multiplied by 1 plus 1 half, because 1 over n plus 1 going to be approaching 0, similar to 1 over n plus 2. And this can be simplified to be 15 over 4. And we can make a conclusion that the series, which is a telescoping series, converges to the value 15 over 4. This example, we have the natural log of the square root k plus 1 over square root k as the end term of this series. Use the log property. From the log of the quotient is the difference of the two log, and also the power 1 half is the same as the square root. So then this series can be rewritten as 1 half as a common factor of the difference of the natural log of k plus 1 and natural log of the k, where k is starting from 1 to infinity. Starting with finding the n partial sum. Which is Sn. Have the common factor 1 half. For k equals 1, we have natural log 2 minus natural log 1, subtracted by, added by, for k equals 2 term, which is natural log 3 minus natural log 2. Next, going to be natural log 4 minus natural log 3 plus more. And then the very last one, or the k equals n, would be the natural log of n plus 1 minus natural log of the n. The one before the last would be the natural log of the n minus natural log of the n minus 1. Again, we can see some terms can be cancelled as natural log 2, natural log 2. And then the next two terms, we can see the log 3 and minus log 3 here cancel. This one cancel. And natural log 4 will be cancelled with the next group. So for the two groups that next to each other, the first term of the first group cancel with the second term of the second group. And also this will be cancelled with the one before. Now we have the simplified Sn as 1 half of negative natural log 1 plus natural log of n plus 1. And we know that natural log 1 is 0. That means the Sn is just 1/2 of natural log of the n plus 1. And take the limit as n approaches infinity. So the limit Sn, n approaches infinity, or the limit of 1/2 natural log of n plus 1 is infinity. It's not a real number, so we can say that the series diverges.